Hey everyone, Mr. Gullen here. We are back at it, lesson 2 in unit 11, and today we're going to get into more detail about outliers, and we're going to talk about percentiles, and I think we're also going to get into a little bit of quartiles as well. You'll see that on the very last slide. We've actually talked about really outliers and quartiles in lesson 1, but we're just going to give you a little bit more detail and some good friendly reminders. So we're going to actually do some calculations of outliers instead of just looking at data and saying, oh, that looks too big or that looks too small. Remember, outliers are anything that look way too large to be in the data set or way too small, right? That's the general definition, but we're going to get more specific with it today. Percentiles is just going to be a way to categorize the data into, 15 numbers are 75% of the data, etc. We're going to be able to calculate, and again, it's just a way to look at different ways to look at data. So let's get it right into it. An outlier. Obviously, it's an extremely high or an extremely low value within the data set. How do we identify the outliers? It must satisfy the following equations. So again, in the first lesson, we kind of just used our naked eye and said, oh, that's too big, so it's got to be an outlier. It doesn't fit. Well, now we're going to get technical, that we are actually going to calculate some numbers to see if we have an outlier either extremely high or extremely low. So here's how you do it. Basically what you do is to formulate this number to determine whether you have an outlier or not is to take the Q3, which is your quartile 3, plus 1.5 times the IQR. Remember, IQR is inner quartile range. Okay? The inner quartile range, remember, is Q3 minus Q1. So we'll review that here in a minute. And then if you whatever number you get here, if you have a number that is larger than this number, then it is an outlier. If you do the subtraction, which when we do a extremely low for outlier, we do subtraction for the low end. If it's smaller or less than this, then it would be an outlier on the low end. Okay? So let's take a look at a problem and practice this. So here's an example. We just call it phone calls received on a given day. So you receive 10 phone calls, 12 phone calls, etc., etc. First thing we want to do is we want to make sure we put this in order. All right? And so I'll do that right now. Basically, we have 10, 11, 11, 11, 12, 12, 13, 14, 14, 15, 17, and 22. All right? And again, if you needed to make that chart or that scale like I did in the first video to put these in order, you could. I kind of pre-arranged them before I started the video, so it went kind of faster for you. But double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'm essentially going to make a box and whisker plot here for us for good review, and it'll help us figure out some outliers. So to the naked eye, right, we're looking at 22 and 10. We're trying to think, okay, could 10 be the low end outlier? Could 22 be on the high end? Could 22 be an outlier? Is really where our brain should be going. So we got 12 numbers, so basically 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So really I have 12.5 here. If I was making a box and whisker plot, I'd have 12.5 for my median. That would be my Q2. And then that we want to find quartile 1 and quartile 2. So we would go 1, 2, 3, 4, 5, 6 there. So right in the middle, and that's going to be 14.5. So here's 14.5 for Q3. And then 1, 2, 3, 4, 5, 6. So right in between there would be 11 plus 11, cut it in half, 11, obviously. And that would be 11, and that's going to be Q1. So if I were to make my box and whisker plot, again, this is a real rough sketch, that's what it would look like. The max would be 22, that's your max. And your min would be 10. That would be your min. Okay, so there's your box and whisker plot right there. So calculating this now, if you go back to the first page, what do we have to do, right? We have to take Q3, we got to take plus 1.5, and then times it by the IQR. All right, so let's do that back over here. I'll switch back to my blue pen. So the upper quartile, or the upper max or outlier that we're looking for would be Q3 plus 1.5, and then the IQR. What is the IQR? That's where we got to take Q3 and subtract Q1. So basically we have 14.5 minus 11, right? And we should just get 3.5, right? 14.5 minus 11, we should just get 3.5. All right, so Q3 is 14.5 plus 3.5 times 1.5 is going to give me 5.25, and I'm going to add that to 14.5, and I get 19.75. So going back to the first slide, I won't go there, but any number that is bigger or larger than 19.75 is considered an outlier on the upper level, all right, or the maximum, the higher numbers. So 22 is an outlier. We would consider that an outlier for sure. Let's test to see if 10 is an outlier. So what we would do is, for the lower end, you don't have to write that, but it's going to be, just look back at the front page, it's going to be Q1, let's see if I can get in there, there it is, it's Q1 minus 1.5 times the IQR. So it's Q1 minus 1.5 times, we already know the IQR is 3.5, so Q1, remember, is 11, get this straightened up, is 11, and then we're going to subtract basically 1.5 times 3.5, and that's going to give us 5.25, so 11 minus 5.25, and we get 5.75. Now, we would have to have a number in our data that is lower than 5.75 to be considered an outlier. Obviously, we don't. 10 is bigger than this, and so 10 is not an outlier. The only outlier we have in this problem would be 22. Okay? So that is how you calculate outliers for given data. Moving on. So now we're going to change gears a little bit, and we're going to move towards percentiles. And before we can really understand percentiles, just a quick review of percentages, right? It says data set, the data set is 1, 2, 3, 4, 5. How many numbers are even? So we're talking a percentage. Well, obviously 2 and 4 are the even numbers. If you want to find a percentage, and I know you guys know this, but just reviewing, just covering all our bases here. To find the percentage, it's the total outcomes that we want. So how many even numbers are there? There are 2. Out of the total number of data sets, or the data points that we have 5 total. And so we would just take 2 divided by 5, which would be 0.4. Now I have here the equation. You can times it by 100, or you can just move that over 2 spots, and you know you have 40%. So 40% of the numbers are even in this data set of 5. That's percentages, okay? Now, I have to have you write down the definition of a percentile. So here's what it is, and this is important. It's the value below which a certain percentage, I'll use the symbol there, a certain percentage of observations lie. Now the key word in this is below, and I'll talk about that here in a second. Values below the percentile, okay? So we have this example here where we have, when we talk about observation, like this is an individual observation 2, this is another observation 3, observation, 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 you get it, okay? So here's all of our data. It's already in order for us, which is nice. It says, what is the percentile ranking of 10? Well, here's observation right here that is 10. So they want to know what percentage of numbers lie below, I'll put a little arrow here, below 10. That's what it's asking you. So what you want to do to find the percentile rank is you take the number of values below the number that's in question right here, which is 10. So we would just count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. And that number would go on top. You can see that here. And that's over n, which represents the total number of pieces, or total number of observations, I guess, if I'm using the technical term. So it's just 16 out of 20. 16 out of 20 would give you 0.8. If you want to times it by 100, you can, or you can just move that decimal place over 2 spots to make it a percentage, and you get 80%. So what does that mean? That means that 80% of the observations in this data set fall below the number 10. So all of these numbers would represent 80% of the observations in that data set. Okay? And now the next slide, what we're going to do is basically going to work backwards. So what this question says is, and it's the same example, same number of observations, what value exists at the percentile ranking of 25%? So again, we're just working backwards here. So here's how you would do it. You would take the percentile, which in this case is 25%, put it over 100, and we times it by basically n plus 1. Okay? Now, why do we times it by n plus 1? Because if we just did n, remember that would give us the number. We want to go one number above because it has to fall below. So that's why we do the plus 1. So, you know, you take 25 and divide it by 100, and you get 0.25, okay? So 0.25. N represents the number of observations. So again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. There are 20 total. And then we plus 1, 20 plus 1, okay? And so basically you get 0.25 times 21 is what you get. And when you do that, you get 5.25. Now, the question says, at what value? So these are your values up here. Well, obviously, there is not a 5.25. Okay? So basically, this means the fifth. This is not the number 5. This is the value number. So 1, 2, 3, 4, 5. This is the fifth observation. That's what I'm basically saying here. It's not. That's a little confusing because this happens to be a 5. But this is representing basically the observation number. This is the in between 5 and 6. So there's no 5.25 value, right? There's just 1, 2, 3, 4, 5, 6. We're just using whole numbers. So what we can do is take the average of the 5th and 6th to find what value exists at the 25th percentile. All right, so we count 1, 2, 3, 4, 5, 6. Right there is in between. We take the average of 5 and 5, so basically 5 plus 5 over 2. Obviously 10 over 2 is just 5. Okay? So 5 numbers represent, the first 5 numbers basically represent the 25th percentile. Okay? So nothing too crazy there. The very last thing is something we kind of talked about before, and this is quartiles. And we've already referenced this quite a bit, but we're just kind of making a point. You can envision this as like a box and whisker plot, because this is essentially what it is. Okay? This is quartile 1, quartile 2, quartile 3. If I put a point there, that would be our max. If I put a point there, that would be our min. Quartiles are what we use to explain and be able to kind of make generalizations about our data from a box and whisker plot. So, you know, your first median here, 50% of the data falls below this, 50% above. At Q3, that represents 75% of your data. Quartile 3 that means 75% of the data is here. 25% would be to the max of or whatever your observations are. All right, and so we've already talked about quartiles, but just breaking down, understanding that you understand that quartile 1 represents 25% of the data. Quartile 2 is 50, quartile 3 75. This would be 0, this would be like your 100, okay? So that's it. That's all we're doing. So a lot of focus on outliers, making sure you know those equations that I have highlighted here in yellow, and then obviously our percentiles, finding the actual percentile, and then actually finding what value, what observation exists at that percentile. Okay? Look forward to talking to you in class. See you then.